Students, today class, draw the position time graph, various cases and velocity time graph. In last class, graphical representation of a motion, the position, velocity, acceleration vary with time. These variation can be shown graphically. So now position time graph, position taken along the y-axis, position, velocity, acceleration taken along the y-axis and time along the x-axis. Now here draw the position time graph. This is a 2-mark question. Draw the position time graph case 1 for a body at rest. So now here a body moving along straight line. Now body move from O to A. After 2 seconds, the body cover 10 meter. So at A, the body will be rest. After 4 seconds also, the body covering 10 meter. Do not move body. The body at rest at A. Only covering how much distance? 10 meter. So after 2 seconds, 10 meter. After 4 seconds also 10 meter. After 6 seconds also 10 meter. Now plot the graph. So now here, so 2 seconds. So in 2 seconds, how much distance will be covered here? 10 meter, maybe 10 meter. So now mark the point here. After 4 seconds, same distance the body covered. So 10 meter. So once again, mark the point here. After 6 seconds also, the body at A, how much covering distance? 10 meter. So after 8 seconds also, same distance 10 meter. 10 meter. Now we join these lines. So this graph shows that for a body at rest, draw the position time graph for a body at rest. Position x taken along the y-axis, time along the x-axis. This graph shows that for a body at rest. So how to write this graph? So now x is a position taken along the y-axis, time along the x-axis. This is a graph. So this line parallel to time at x-axis. This curve or graph, this line parallel to where? X-axis. So this graph indicates for a body at rest. So this is 1 mark first graph. Draw the position time graph for a body at rest. So a y-axis indicate x is the position, t is the time. And this straight line parallel to x-axis. So this graph, it shows that for a body at rest. This is the first graph. After second one, draw the position time graph for a body moving with uniform velocity. Now we are body moving along straight line. After 2 seconds, 10 meter. 4 seconds, 20 meter. 6 seconds, 30 meter. So 8 seconds, 40 meter. Now mark the point. So here 2 seconds. So maybe get straight line. Get straight. So draw the position time graph for a body moving with uniform velocity. So this graph gets straight line. So this is a 2-mark question. Students, draw the position time graph for a body at rest, for a body moving with uniform velocity. The 2 graphs is very important in examination. So the first graph for a body at rest, second graph for body moving with uniform velocity. Students, now second graph, draw the velocity time graph. So velocity taken along y-axis, time along the x-axis. Now the first graph for a body moving with uniform velocity. Example, a vehicle moving on the road. So after 2 seconds, which cover the speed may be 10 meter per second. This is a 10 meter per second here. After 4 seconds, also the vehicle maintaining speed 10 meter per second. So after 4 seconds, next after 6 seconds also same speed. Now look at the board here. A vehicle moving on the road. After 2 seconds, the vehicle maintaining maybe 20 meter. After 4 seconds, same 20 meter per second. 6 seconds, 20 meter per second. 8 seconds, 20 meters per second. So now join this line. So this graph shows that for a body moving with uniform velocity, every 2 seconds, which maintain same speed, same velocity, so that graph is parallel to the x-axis. So the first graph here, velocity taken along the y-axis, time along the x-axis. Draw the velocity time graph for a body moving with uniform velocity. So the body moving on the road. So after 5 minutes, how much speed is maintained? Next 5 minutes also same speed, same velocity. Every 5 minutes or every 4 minutes, maintaining equal speed, equal velocity. This graph. For example here, so after 2 minutes, maybe 10 meter per second. After 4 minutes, so 10 meter per second. After 6 minutes, 10 meter per second. Every time which maintain same velocity. So this graph is a for body moving with uniform velocity. Uniform velocity. So draw the velocity time graph, uniform velocity. Now first you represent V. Velocity taken along the where? So y-axis. Time along the x-axis. This line parallel to x-axis. This graph indicate or shows that for a body moving with uniform velocity. And second graph, uniform acceleration. Uniform acceleration. Uniform acceleration. Uniform acceleration. So uniform acceleration, velocity taken along the y-axis, time along the x-axis. Time along the x-axis. So after the vehicle moving on the road, after 5 minutes, maybe 10 meter per second. After 10 minutes, so 20 meter per second. Each and every time, so the velocity may be increased. So now get straight line. So this graph it shows that for a body moving with uniform acceleration. For example, so 2 minutes, maybe 10 meter per second. After 4 minutes, 20 meter per second. After 6 minutes, 30 meter per second. 8 minutes, 40 meter per second. So after, so every 2 minutes, whatever velocity may be increased. So then graph it shows get straight line. This is straight line. So this graph indicates for a body moving with the uniform acceleration. This is the second graph. And third graph, for a body moving with uniform acceleration with initial velocity. With initial velocity. Initial velocity. Draw the velocity time graph for a body moving with uniform acceleration with initial velocity. So velocity taken along the y-axis v. So after time taken along the x-axis. For a body moving with uniform velocity, a vehicle, a beginning which maintain so initial velocity maybe so 10 meter or 20 meter per second. So after 4 seconds, after velocity may be increased. So this graph. So beginning initial velocity. So after velocity, time increase, velocity will also increase. initial velocity. U is an initial velocity. After certain time, velocity time increase, velocity is also increase. So this graph indicates what? For a body moving with uniform acceleration with initial velocity. In beginning, a vehicle use mean time maybe 10 or 20 meters per second, certain time. So after the speed of the vehicle increase, velocity is also increase. So this graph it shows that for a body moving with uniform acceleration with initial velocity. So these three graphs is very important. Draw the velocity time graph, uniform velocity, uniform acceleration with initial velocity. This graph, U is the initial velocity. Students, so now your one question is the 3 marks question. What is VT graph? Show that area under VT graph is equal to distance or displacement. It is very important. This is a 3 marks question. What is a VT graph? Show that area under VT graph is equal to distance or displacement. So already you know the VT graph. Velocity taken along y-axis, and time taken along the x-axis. Time taken along the x-axis is the time. Time taken along the x-axis. Time taken along the x-axis. Velocity along the y-axis. Velocity along the y-axis. So draw the velocity time graph for uniform velocity. Uniform velocity every 2 minutes or every 5 minutes the vehicle which maintain same speed, then you get nature of the graph. So this graph is straight parallel to x-axis. Every 5 minutes or every half an hour, every 10 minutes a vehicle with maintain uniform velocity. So then graph, for example, after 2 seconds, so maybe 20 meter per second, after 4 seconds, 20 meter per second, every time we maintain same speed. So you get straight line. This is a graph parallel to x-axis. Now this graph join here rectangular. Now this is rectangular. Now here O, here A, now here B, this is a C. Students, look at here, please see that. You forget this line. This AB parallel to x-axis. AB parallel to x-axis. This graph shows that a body moving with uniform velocity. Uniform velocity every time, every 10 minutes or every 15 minutes, maintaining same speed or same velocity, the uniform velocity. The body covering equal distance in equal interval of time, that is uniform velocity. So now here AB, the line AB parallel to x-axis. This graph shows that the time AB is parallel to x-axis a graph, the velocity time graph for body moving with the uniform velocity. So after join this one. So now here this area. So what is the structure of here? O, A, B, C. Now this is the one rectangular. So OA, which axis? Y-axis. Y-axis you take what? Velocity. So V. Okay, after OC. In x-axis what? Time T. So OABC is a rectangular. So area of the rectangular. Area equal to what? Length into breadth. the area of the rectangle OABC. Area of the rectangle. Area equal to what? Length into breadth. So now area. So area equals A equals length. Length means what? So here length. Taken what? Velocity V. And breadth. This is the breadth OC. What? Here time T. This is equation number 1. So area under VT graph. Area under the VT graph equals area under VT graph. Area under VT graph. So equal to what? Length into breadth. Length what? V. Velocity. Breadth means OC at that time. So the equation number 1. So after velocity. Velocity equal to what? Displacement. Displacement by time. Time taken. So now V equal. So V equal to what? Yes. Displacement means yes. Or distance traveled by T time. So now take cross of S equal to distance equal to V into T. Equation number 2. Velocity equal to displacement by time. So V equal to displacement or distance traveled S. So S equal to V into T. Now equating from equation 1 and 2. So here 1 and 2 what? Area under VT graph. Area under VT graph equals what? Yes. S is a distance traveled. Distance. Now your question is what? Show that area under VT graph is equal to distance. So how to prove the above equation? Velocity taken along y-axis, time along the x-axis. For a body moving with uniform velocity, this is A. The line AB parallel to x-axis. Every time, every second, or every minute, a vehicle maintaining same speed, same velocity. The body moving in the same direction, equal distance, in equal interval of time, that is called uniform velocity. So AB is a uniform velocity. Parallel to x-axis. Now join this BC. Now this is a rectangle. So area under VT graph. Area equal to general formula. Area equal to length into breadth. So area under VT graph equal to length means, so this one length. OA equal to what? V, velocity. Breadth, OC, that is the time. So T. So area under VT graph equal to V into T. Equation number 1. So after velocity V equal to displacement by time. So V equal to displacement S, that is the distance, time T. So S equal to V into T. S is a distance or displacement. Now equating from equation 1 and 2. So equation number 1 what? Area under VT graph equals V into T. V into T equal to what? S. S is called displacement or distance traveled. Therefore, area under VT graph equal to distance. Now question here, area under VT graph is equal to distance or displacement. This is a 3 marks question. What is a VT graph? Show that area under VT graph. So the graph obtained by plotting velocity along the y-axis, time along the x-axis is called a VT graph. So after you prove this one, area under VT graph is equal to distance. So now area under VT graph equal to V into T. S equal to V into T. Equating from equation 1 and 2. Finally you get area under VT graph equal to distance travelled.